56%, more than half of all the copper the world needs for its electric vehicles, its wind turbines, its power grids, its semiconductors. More than half of it comes from one corner of South America, and right now that corner is in trouble in ways that the mainstream financial press has been seriously underreporting. Chile's copper export challenges are not a minor supply disruption story. They are a structural vulnerability story that sits at the center of the global energy transition, the technology competition between the United States and China, and the inflation outlook for every American who buys anything that requires electricity to operate. Copper is the metal that makes the modern world function. Everything about the energy transition requires more of it. Electric vehicles use 3 to 4 times more copper than internal combustion engine vehicles. Offshore wind turbines use 10 times more copper per megawatt of capacity than coal plants. Expanding power grids to handle electrification require copper at scale that current mining production is struggling to match. And Chile, the country that produces more copper than any other nation on Earth by a factor that dwarfs the second-place competitor, is facing a set of converging challenges that should be generating far more alarm than they currently are. This channel runs on no corporate sponsorship, no government backing, no editorial pressure to soften the numbers. If understanding the commodity foundations of the technology war between the US and China matters to you, subscribe now. Let's look at what's actually happening in Chile and why it matters everywhere. Here is the ground reality in Chile's copper sector. Chile's 2 largest copper mines, Escondida, operated by BHP, and Collahuasi, operated by Anglo American and Glencore, are the largest copper mines on Earth by production volume. Together they produce enough copper to supply a substantial fraction of global demand, but both are experiencing what geologists and mining engineers call grade decline. The ore they are extracting contains progressively lower concentrations of copper per ton of rock mined. Escondida's ore grade has declined from approximately 1.3% copper in the early 2000s to under 0.8% currently. At that grade, you need to move and process significantly more rock to produce the same amount of copper. Processing more rock requires more energy, more water, more equipment, more time, and more capital. Production costs rise, margins compress, investment in expansion becomes harder to justify at existing copper prices. The water problem compounds the grade problem in ways that are not linear. They multiply. Chile's Atacama Desert, where major copper deposits are concentrated, is one of the driest places on Earth. Mining operations there depend on water that is increasingly scarce as climate patterns shift. Lithium mining in the same region, itself booming due to electric vehicle battery demand, competes for the same water resources. Indigenous communities holding water rights have become more assertive in protecting those rights, creating legal and regulatory complications for mine expansion permits. Desalination plants are being built to reduce freshwater dependency, but desalination adds cost, requires coastal infrastructure, and creates its own environmental permitting challenges. Water stress in the Atacama is both a current operational constraint and a long-term structural cap on Chilean copper production growth. And then there is the energy cost dynamic. Copper smelting and refining are extremely energy-intensive processes. Chile's electricity grid has been shifting toward renewable energy, which is positive for emissions profiles, but the transition has created price volatility and reliability concerns that mining operations, which require stable, high-volume power supply, find operationally challenging. Energy costs as a share of Chilean copper production costs have been rising. At a moment when copper price volatility makes margin management critical, rising energy costs are squeezing producer economics in ways that reduce reinvestment appetite. Here is what the official Chilean mining ministry statements are not saying plainly. Chilean copper production has been essentially flat for several years at approximately 5.4 to 5.6 million metric tons annually. The production plateau is not a choice or a policy decision. It is the operational reality of grade decline, water constraints, energy costs, and the increasing complexity of operating in a regulatory environment where environmental and indigenous rights considerations have appropriately gained more weight. Chile's state copper company, Codelco, the largest copper producer in the world, has been cutting costs aggressively while simultaneously trying to fund major structural projects at its aging flagship mines that are essential to preventing production declines. Codelco has been running at debt levels that limit its capital investment flexibility, precisely when capital investment is most urgently needed. The math here is where the concern about Chile's copper challenges transitions from a mining sector story to a global economic story. Global copper demand is projected to reach 40 to 50 million metric tons per year by 2040, compared to approximately 26 million metric tons consumed in 2024. That is a gap of 14 to 24 million metric tons that does not currently have identified supply to fill it. The copper deficit projected for the 2030s, the gap between projected demand and projected supply from currently operating or firmly planned mines, is the largest projected supply gap in any industrial metal in history by several measures. Goldman Sachs research described copper as the new oil in terms of its strategic importance to the transition economy. The comparison understates the challenge because oil has numerous substitutes and various applications, while copper's electrical conductivity properties have no cost-effective substitute for most of its primary uses in wiring, motors, and power transmission. Chile producing 5.5 million metric tons annually against a projected global demand of 45 million metric tons means Chile's share of global supply declines from 28% today toward 12% by 2040, not because Chile produces less, but because global demand grows faster than Chilean production can match. Every percentage point of Chilean production growth that doesn't happen due to grade decline, water constraints, or regulatory delays represents copper supply that must come from somewhere else at higher cost and longer development timeline. The somewhere else is the question that is driving geopolitical competition right now. China controls approximately 40% of global copper smelting and refining capacity, the processing step between mined ore and usable copper. Chinese companies have been acquiring copper mining assets across Africa, particularly in the Democratic Republic of Congo and Zambia, which together constitute what geologists call the Central African Copper Belt, one of the few regions with sufficient undeveloped copper reserves to meaningfully close the projected supply gap. Chinese investment in DRC copper has grown from negligible levels 15 years ago to controlling positions in multiple major mines, including Tenke Fungurume and Kasanfu, which together hold copper and cobalt reserves valued at hundreds of billions of dollars. The strategic architecture that China is building in global copper supply is directly analogous to what it built in rare earth elements in the 2000s, and the lesson of rare earths is instructive. When China established dominance in rare earth supply and processing in the 1990s and 2000s, Western countries paid minimal attention. Then in 2010, China restricted rare earth exports in a dispute with Japan. The price shock was severe, and the supply chain vulnerability it revealed was shocking to governments and industries that had complacently allowed themselves to become entirely dependent on Chinese rare earth supply. The result has been 15 years of expensive, politically complicated, still incomplete efforts to rebuild non-Chinese rare earth supply chains. The United States, Europe, Japan, and South Korea are all spending billions of dollars trying to undo a dependency they could have prevented. Copper is following the same trajectory. China is not yet in a position to restrict copper supply the way it restricted rare earths because too much copper comes from non-Chinese mines. But China's dominance in smelting and refining, the processing capacity, creates a different kind of leverage. If China controls where the world's copper ore gets processed into usable metal, it has influence over copper supply chains that mine ownership alone does not provide. Here are my 3 predictions with specific timeframes. First prediction: within 24 months, the United States will announce a formal critical minerals agreement with Chile, likely as part of a broader trade and investment framework that includes American financing commitments for Chilean copper mining infrastructure in exchange for supply guarantees and reduced Chinese investment exposure in Chilean mining assets. The Biden administration began this negotiation. The current administration will either complete it or replace it with a differently structured but functionally similar arrangement driven by the same supply chain vulnerability logic. Second prediction: within 36 months, copper prices will exceed $12,000 per metric ton, roughly 30% above current levels, as the supply deficit becomes too obvious to price otherwise. At $12,000, copper projects that are currently marginally economic become viable, but the development timeline for new mines means meaningful new supply does not reach market for 5 to 7 years after investment decision. The price spike will be real. The supply response will be delayed. The gap in between gets absorbed by industrial consumers in higher product costs. Third prediction: Within 5 years, the Democratic Republic of Congo, not Chile, will be the central country in the global copper geopolitical competition. Congo holds the copper and cobalt reserves that can actually close the projected supply gap. The contest for control of Congolese mining assets between Chinese state-backed companies, Western mining majors, and American government-backed investment vehicles will be the defining resource competition of the late 2020s. Chile's challenges will have accelerated the urgency of the Congo question by removing Chile as the easy answer to copper supply deficit concerns. What is at stake in Chile's copper sector challenges is nothing less than the physical material foundation of the energy transition, the technology competition, and the next generation of industrial production. You cannot build electric vehicles without copper. You cannot build wind turbines without copper. You cannot expand power grids without copper. You cannot build the semiconductor fabrication plants that the United States is investing billions to repatriate without the copper wiring they require. Every strategic priority in American industrial and energy policy traces back to copper supply at some point in the supply chain. Chile's challenges are not Chile's problem alone. They are everyone's problem. And the solutions, new mines in new geographies, new processing capacity in non-Chinese jurisdictions, new recycling infrastructure to recover copper from the existing installed base, all require capital, policy commitment, and strategic clarity that are in short supply relative to the urgency of the situation. The energy transition will be built with copper. The question is whose copper, processed by whom, controlled by which governments, and available at what price. The answer is being determined right now in Chilean mining districts. Congolese mineral concessions and Chinese smelter capacity decisions will shape the economics and the geopolitics of the next 30 years. Drop your prediction in the comments. Does America develop a serious copper supply chain strategy in time to avoid the rare earth dependency trap, or does the same complacency repeat itself with a metal that is orders of magnitude more important to the overall economy? Tell me your read. I want to see the community's analysis. If this gave you a framework for understanding why Chile's mining sector problems are your problems too, share it with one person who needs to understand the commodity foundations of the technology competition. The next video goes somewhere even this one didn't reach. Subscribe so you're there when it lands. Let me take you deeper into the technical and political dimensions that create the full picture of why Chile's copper challenges represent a first-order strategic concern for the United States. The copper recycling equation is the first dimension that most analysts overlook. Approximately 35% of current global copper supply comes from recycled copper, recovered from demolition, from end-of-life vehicles and electronics, from industrial scrap. At current recycling rates and current infrastructure, the recycling contribution to global copper supply is essentially tapped out. Increasing recycling rates requires investment in collection infrastructure, sorting technology, and processing capacity. It requires policy frameworks that incentivize recycling over landfill disposal, and it has a hard ceiling. You can only recycle copper that has already been mined and placed in service. If the installed copper base is insufficient to meet future demand even at 100% recovery rates, recycling is a complement to mining, not a substitute for it. The math of copper recycling does not save you from the copper mining problem. It delays and reduces, but does not eliminate the supply gap. The substitution question is the second dimension. Can materials other than copper substitute for copper's role in electrical applications at acceptable cost and performance? Aluminum can substitute for copper in some wiring applications and has been used in residential wiring with mixed results. Aluminum's electrical conductivity is approximately 60% of copper's, meaning aluminum wires must be larger in cross-section than copper wires to carry equivalent current. For large-scale power transmission over long distances, aluminum is already standard and works well. For the high-density, high-performance wiring in electric vehicle motors, in wind turbine generators, in semiconductor fabrication tools, and in high-frequency electronics, aluminum does not perform adequately. The physics of electrical resistance and thermal management in compact, high-power applications keeps copper irreplaceable in exactly the highest growth applications, driving demand increase. Superconducting materials offer theoretical future substitution possibilities, but remain expensive, require extreme cooling, and are decades from commercial deployment at infrastructure scale. The bottom line on substitution, it is not coming fast enough or at sufficient scale to materially reduce the copper demand trajectory over the planning horizon that matters for current investment decisions. The recycling ceiling and the substitution gap together mean that new copper mining is the only mechanism available to close the projected supply deficit at the scale required by the energy transition and technology build-out. New copper mining means new mines in new geographies under new ownership structures, and the competition to control those new mines is the resource competition that will define the first half of this century in ways that the oil competition defined the second half of the last century. Chile's challenges accelerate the urgency of this competition by weakening what was the most reliable, most transparent, and most Western-aligned major source of global copper supply. As Chilean production growth stalls and Chilean mines require increasing capital just to maintain flat production, the incremental supply must come from places that are less transparent, less politically stable, or more Chinese-influenced in their ownership and processing arrangements. That shift in where marginal copper supply comes from is a shift in who has strategic leverage over the technology competition and the energy transition. The Pentagon understands this. American defense procurement depends on copper for virtually every weapon system, every communication system, every power system in the U.S. military's inventory. Defense Department analyses of critical mineral supply chain vulnerabilities consistently identify copper as a concern, despite its relative abundance compared to rare earths, precisely because the concentration of processing capacity in Chinese hands creates a potential leverage point in a conflict scenario. Defense concerns about copper are not about peacetime price or availability. They are about what happens to American weapons manufacturing capacity if Chinese copper processing is disrupted or restricted in a high-tension scenario. This is the most under-discussed dimension of the copper story in mainstream coverage. Copper is not exotic enough to generate the alarm response that rare earths or lithium generate. It is familiar. It is used everywhere. Its ubiquity creates a false sense of security about its supply, but ubiquity of use and diversity of supply are different things. Ubiquity of use, combined with concentration of processing, creates vulnerability. And that is exactly the copper situation the United States faces. The Chilean government's response to this situation has been caught between legitimate national development interests and the geopolitical pressure being applied by multiple external actors. Chile wants maximum value from its copper resources, which means processing more copper domestically rather than exporting raw ore, which means developing downstream industrial capacity, which means attracting investment on terms that maximize Chilean economic benefit rather than simply maximizing extraction speed. These are reasonable national development goals. They are also goals that create friction with international mining companies seeking maximum production efficiency and with political frameworks that prioritize supply security for importing nations over value-added retention in producing nations. The tension between Chile's legitimate development aspirations and the international supply security imperative is not resolvable by simple commercial arrangements. It requires the kind of long-term economic partnership frameworks, investment in Chilean industrial development, technology transfer, educational investment, and market access guarantees for Chilean value-added products that only government-to-government engagement can structure at the required scale. The United States has the capacity to offer this kind of engagement. Whether it develops the political coherence and sustained commitment to do so is the question. History on critical mineral supply chain development suggests the answer has usually been inadequate until a crisis forces urgency. The question is whether the copper situation generates sufficient proactive urgency to be the exception to that pattern. The copper in your car, your phone, your home's electrical system, the power lines that deliver your electricity. It has a supply chain that runs through Chile, through the Democratic Republic of Congo, through Chinese smelters, and through a geopolitical competition that is as consequential as any military confrontation, but receives a fraction of the strategic attention. Chile's export challenges are your challenges. The global market concerns are legitimate. And the window for developing supply chain solutions before the deficit becomes a crisis is narrowing with each year that passes without decisive action. That is the full picture. That is the analysis you will not find in a 3-paragraph commodity market brief. Stay here for the full picture. There is a final dimension to Chile's copper story that connects everything else, and that almost no mainstream analysis has placed in its proper context. It involves the relationship between Chile's copper challenges, the global electric vehicle transition timeline, and the specific competitive position of American automotive manufacturers relative to Chinese EV producers. The electric vehicle transition is often discussed as a clean energy and climate story. It's also a copper story. A conventional gasoline-powered car uses approximately 20 to 25 kilograms of copper in its wiring, motors, and electronics. A battery electric vehicle uses 60 to 80 kilograms of copper. An electric vehicle charging station uses 5 to 10 kilograms of copper per unit. The infrastructure required to support widespread EV adoption, the expanded grid capacity, the transformer upgrades, the charging networks, requires copper at a scale that dwarfs the copper in the vehicles themselves. The United States has committed to aggressive EV adoption targets. The Biden administration's target was 50% of new vehicle sales being electric by 2030. Current market trajectories suggest that timeline faces challenges, but even a more gradual adoption curve represents an enormous increase in copper demand. The EV supply chain, from battery minerals to charging infrastructure to vehicle manufacturing, all converges on copper availability as a foundational constraint. Chinese EIV manufacturers, BYD, SAIC, Geely, NIO, and others, have built their production scale within a supply chain architecture that includes Chinese copper processing as a foundational element. Chinese EV producers do not face the supply chain security concerns that American producers face because the Chinese supply chain is vertically integrated in ways that the American supply chain is not. Chinese companies mine copper in the DRC, process it in Chinese smelters, manufacture copper components in Chinese factories, and assemble them into Chinese vehicles, all within a national supply chain that is insulated from Western supply chain disruptions or pricing pressures. American EV manufacturers, Tesla, GM, Ford, Rivian, operate in a supply chain that is more exposed to global copper market pricing and availability than their Chinese competitors. When copper prices spike due to supply constraints, American manufacturers face higher input costs faster than Chinese manufacturers who have secured supply at longer-term contracted prices through state-backed procurement mechanisms. The competitive disadvantage is not catastrophic in a single year. Compounded over 5 to 10 years of supply chain competition, it could represent a structural cost disadvantage that affects market share. Chile's copper challenges therefore connect directly to the competitiveness of American EV manufacturers relative to Chinese competitors. It is not an abstract commodity story. It is an industrial competition story with the American automotive industry's future position in it. Every mining permit delay in Chile, every water rights dispute in the Atacama, every year, the Chilean copper production growth remains flat rather than expanding. Each of these events moves the global copper supply balance in ways that ultimately affect what American consumers pay for electric vehicles, whether American manufacturers can compete effectively with Chinese alternatives, and whether the energy transition proceeds at the pace required by climate commitments and strategic interests simultaneously. The connections are real. The math supports them. And the window for proactive supply chain strategy is right now, not after the deficit becomes a crisis and the leverage shifts entirely to those who prepared in advance. This is the analysis that matters. This is the picture that needs to be understood. And this community is where that understanding is being built.